I want to talk specifically about boiler waterline controls. All right, let me just put this down. You guys are pretty familiar with this. Maybe some of the younger guys that are in the boiler rooms are not so familiar with it, and you just sort of do it because someone said, put the 51 feet here. On the boiler waterline, and I'm going to probably go back and forth a little bit on this. The boiler waterline, no. Okay. This is a 51 feeder on the right side, that black box. No, look at this, hold on. I'm learning as I go here too. I have my pointer now, look at this. We don't have to step in front of the screen anymore. Right here, that's the 51 feeder. The 51 feeder is supposed to be mounted at the side of the boiler, okay, and it's used for gravity return lines. Gravity return lines are steam systems that do exactly that. The steam goes out into the header, and it comes back by gravity. There's no pump returns. The 51 feeder is a mechanical feeder. There's a float ball inside there that will lower, well, why's my hand shaking like that? Look at that, too much Red Bull. That will lower, look at that. That will lower itself. When the water drops in the boiler, it will raise itself back up and seal. The water comes in through this backflow preventer. That's the backflow preventer. The water meter goes up through this open valve. When the flow drops, it goes back, it feeds into the boiler on the bottom here. There's a check valve on the bottom of the equalizer. That will maintain the water level at the proper height. Now, there's some play in the 51 feeder in the mounting height. If you look in your handouts, the line is the casting line right here. There's a casting line, okay? That is not to be set up at the exact height of the water line, but it's to be set a little lower. And we've been doing it for a long time, and I actually haven't done it for so many years. I have to ask Vinny because I forgot, what we were setting at. It turns out we're doing it at 2 inches. Okay, so the casting line is set 2 inches below the normal operating boiler water line. The normal operating boiler water line is the center of that pipe, which is actually in the front of the boiler, center of the coil. The 51 feeder is used on 150 horsepower boilers and less. The next control that we would use see what happened? The next control we'll use would be the 51S. The 51S is another mechanical feeder, but it's fast. It works for the bigger boilers up to 250 horsepower. Those boilers are steaming at a much faster rate. The 51S will let the water in on it faster. It actually looks like an S pattern. You'll see it on the larger jobs, gravity return system. The same thing, they're set about 2 inches below the center of the water line. There are times where that 2 inches is too high or too low. And that's basically, it depends on how fast the return water gets back into the boiler. If it's a large, long boiler, the return takes a long time, and it's called a system lag time. And if that's the case, if you have a long lag time, say 45 minutes from the time of the start of the cycle till it starts returning back, you actually sometimes have to go back and lower the water line. Because what happens is, as the boiler cycles, after the second cycle, there'll be too much water in the glass. It'll rise itself because it's sending fresh water in, replacing the steam, which goes out into the system, giving up its heat, condensing back into condensate, returning back into the boiler. At that point, 45 minutes later, with that feeder feeding constantly, you have too much water in the water line, okay? And what happens on the next cycle is that water will turn into saturated steam, and it will send up wet steam into the system, which we'll talk about on a few more slides going forward. So that 51 feeder is adjustable. We find that 2 inches works most of the time. There are some occasions where we have to go back and adjust it. In that case, usually we're out of the job, and the service department will handle that. Does anybody know this job? It's a really nice job. We actually had this in some of our pictures. This is 3620 Bound Street. Remember that job, right? You won't forget. We did a video of that job. That's a, yeah, that's a short bat boiler. This boiler, I think it's 150 horsepower.
How do you know it's a deboiler, guys?
D boilers. Anybody know the difference between A, B, C, and D boilers?
Deboiler, clear indication. Because it has a ladder.
Anything over 96 inches, need a ladder. Good point, Vin. All right, I want to go into pump return. All right, so we have gravity returns, and we're using 51 feet. There are other controls I don't want to get into. I don't want to confuse you, because that's pretty much our industry standard, what we use, what Abilene use. Abilene standard is a 51 feeder. When we get into boiler waterline controls for pump returns, we get into what's called a McDonnell Miller 150S. That's a standard pump control. Let me get you a picture of that. All right, this is 157, and do I have a 51 feet? No. Let me go back. This is actually a 157 pump control. The 157 is usually specified by the engineers. The reason the engineers specify it is because it has a built-in gauge glass. If you could see right here, that's the gauge glass. That's your normal, that will show your normal water line. In this case, the water line is, if you can see here, it is the center of the coil, and it goes across, and there's your water right there. The casting line is 1 3/8, mounted 1 3/8 below your operating water line. By the way, it's in your literature, that a handout, so I gave you all the literature. You can take time and read it and study it and understand and actually go back to the boiler rooms and now you see why we're doing this. Well, what happens is this pump control is tied in electrically to the boiler feed pump, which I don't have a picture of, but the boiler feed pump pumps the return back to the water, to the boiler. The condensate is collected, the steam goes out into the building, it condenses back into condensate and gets stored back into the condensate receiver. This actually won't take too long. Does anybody have any questions on those first, or any of these pictures? Any questions? I'd like to address them as we go instead of stopping at the end. Anybody have any questions about the 157 or the 150 pump control? No? Okay. All right. So we went through that. Now we're going to talk about the safety controls. There's really not much more here. The McDonnell Miller number 67 is our primary low water cutoff. And I want to go back. And they are mounted 1 inch above the lowest permissible water line in the boiler. 1 inch below. You see this reversing chamber here, okay? If you take a line and you stretch that across, that would be the casting line. That casting line is there's a little float switch inside there. When that float drops, it will shut the burner. So it's a safety device. If the burner runs out of water, we want it to shut down. We don't want the fire to go into the burner while there's no water in it. And there are times, because that is a mechanical device, that will fail. To ensure additional safety, we put in the McDonnell Miller Series 800M, which in this case, this is an OEM. That's mounted directly into the boiler shell at the boiler, the highest tube, and it's usually welded in the boiler for us. We don't have to think about it. It's done, it's there, it's the last resort for having a problem with the boiler. Any questions about, by the way, why is it a manual reset? Can anybody answer that question? The low water cutoff, the lowest low water cutoff. If it, say again? Anybody?
Top one to be a bottom one.
But why is it a manual, what does manual reset mean?
That you can go and put it down manually after it's fixed.
Right, it will not restart on its own. It's not self-cycling. The 67 is self-cycling. If it shuts off and the pump catches up, the water gets above that line, it will start up the burner again. If the secondary one fails, we don't want that burner to start up. We want someone to come down and reset it and find out what the problem is. We don't want to manually. We want someone, an operator in that room looking for it. It's a safety device. There are other manual controls too. That's the steam control up top, and there's a little red button there. That's the steam pressure control. If the steam pressure gets up above, we usually set it for 10 pounds, and that means there's something dramatically wrong there. It'll shut the burner, and it will not restart. That manual reset will save a lot of problems, because if that fails, the next thing we have is in the back here, these safety pop-offs. Those safety pop-offs will start weeping at about 13 pounds. They're rated for 15. They'll start full opening at 15. That's why we set the manual reset at 10. Safety device, it's very important. We don't want it recycling on its own. This control here would be the A control. That would be the operating control of the boiler. The operating control is usually set, I like 2 PSI. My man over here likes 5.
But not necessary work.
Not all the time, and we'll go into venting and other reasons why 2 PSI is the right for most buildings in this city. All right? And L91 is a modulating control. You can give the next seminar on that because you're an expert there. And I mean that true. You could certainly do that. Better than I can right now. I've been out of the boiler room way too long. All right. All right, so we have the 800. We talked about that. We have the secondary. We talked about that. We went backwards. Let me go this way. Let me go forward. All right, near boiler piping rules. This is stuff for the header rules for trying to create dry steam. The bottom of the steam header, let's go back. Bottom of the steam header, this is your steam header coming out of the boiler. The bottom of this pipe needs to be a minimum of 24 inches below your operating water line, which is there. I'm getting steady, you see that? Look at that, look at that. We're almost there. A few more minutes. It's wearing off. The Red Bull's wearing off. The bottom of the steam header must be a minimum of 24 inches above the water line. Why? The higher the better, because as the steam rises up out of the boiler, the droplets of water return back into the boiler. The more turns and elbows it takes, picture the steam here. Picture the water in the boiler. The burner fires up, and the burner's down here. It starts making steam, and this upper portion of this gauge glass would be called the steam chamber, okay? The steam chamber will start, it'll be bubbling. It'll start making steam, like on a pot of water on a stove. The upper, if you put a cover on it, and you put a little vent on it, you'll see it start bubbling. Same thing happens in the boiler, except it's much more violent. Well, it's bubbling, it's looking to release itself, so it rises up out of the steam pipe, and it condenses in this pipe, the initial stages of it, and the bottom portion of this pipe is filled with water, and it rolls itself right back down into the boiler. That goes into the other side, which is the equalizer. Now, what happens is the condensate is rolling back to the boiler. The steam makes a sharp turn up, drying itself out even more, goes up and starts running into the house distribution system. Now, what happens if this pipe, and there are some occasions where we've had to pipe them very low. We have very low ceilings. In most instances, we don't do it unless we have to, okay? 24 inches is the minimum. We can always adjust the firing rate when we have those rare circumstances, slow the firing rate down and slow the steam down a little bit. But let's use 24 inches as our rule of thumb. If you can make it higher, make it higher. It's better. Are we getting this? You hearing what I'm telling you? I'm trying. All right, there's a nice job. There's a nice picture of a header. Same thing. It's all insulated. See the arrows? I love the arrows on that. It's showing the flow of the rate of the flow. Here's a 157 pump controller. Here's a 67 cutoff. And I think I had a reason for this. Here's the reason. The next slide, I believe, will tell me. There it is. All right. There's a coil. This is your submersible coil in the top of the boiler. Now, if this coil was straight across, it would actually be halfway above the water line. And this is not a great picture because you can't see the exact level. This is your submersible coil. If you look at the coil tappings, the coil pitches itself downward into the water, submerges itself, and sits on top of the tube. 5.5 inches. That 5.5 inch line is crucial to us because that ties together all of the lines that we need all of the water lines, we have 6 inches of water space that we have to get in the Hartford loop. We have to get in the primary low water cutoff, the secondary low water cutoff, and the boiler operating control. That's why that offset is, and get the water hot in that coil. So all these lines tied together, and if you actually, I was trying to get a picture made up where we show all these lines on one. I'll give it to you next time. I'll have Peter make it up, and we'll have it, use it as a training guide for the new guys. We'll be able to, by the way, you guys hear me okay back there? Am I speaking loud enough? Okay. I want to get into, all right, we can do this. I just wanted to show you a 3-pass boiler. We should be familiar with this. Some of you new guys might not understand this, and we're assuming you do. So here's what happens. This is a 3-pass boiler, which is what we use. We manufacture them. Best boilers, best boiler in the business. So throw a plug in there. The burner comes on. You see a little flame? By the way, the blue is water, okay? The red is the heat. The flame comes on. It goes into the rear of it goes through the firing chamber. It hits the rear tube sheet and turns around into the second pass. Okay, here's your first pass. Now you have the flame and the heat coming through the second pass. The water around it starts to get hot. It hits the reversing chamber, makes another U-turn, and the flame and the heat go directly into the exhaust, at the same time giving up its heat. At that point, it starts to make steam, okay? So that's why when you hear 3-pass boilers, that's exactly the reason for it. It's 3 passes. Any questions on that? 3-pass boilers? Any comments? Did I forget something? Anybody else? No? Okay. Did I explain the Hartford loop? And the equalizer. I don't know if I did that. Hold on a second. You know what? Let me go back. I believe I skipped the page here. Oh, you know what? I'm missing a slide. I am. I'm missing a slide. Okay. I don't have the slide. But I want to explain it to you anyway. When you get back in the boiler room tomorrow, ask someone to explain, if you're not sure about it, the steam equalizer. The steam equalizer is this pipe on the side of the boiler that pitches its way down and is connected to the return. That will equalize the pressure between the top of the boiler and the bottom of the boiler, preventing the water on the bottom of the boiler from pushing its way out when the boiler is making steam. It's an equalizer, and it does exactly that. It equalizes the pressure in the bottom of the boiler and also in the return. So that's a very important feature. There's a slide that's missing for the Hartford loop, which is a pretty important slide. The Hartford loop is on the gravity return. Let me go back. I actually have, okay, here's a Hartford loop. Actually, here's an equalizer and Hartford loop. There was another slide I had with some other pictures on it. This is your equalizer. This is your return. You notice how the return comes up and it comes into a T? Would be, imagine the water coming back through here and then sliding into this pipe, the steam pushing it down, the return has to go back into the boiler. That's the Hartford loop. Now, that's an important feature. That was actually designed by someone from the Hartford Insurance Company at the turn of the century. When they first had steam boilers, they were coal-fired boilers. The coal took very long to heat up, and it took very long to cool down. If the operator happened to not be paying attention, was up in the building doing something, sweeping the floor, whatever he was doing, and there was a break in this line, they used to attach this pipe right directly to the boiler on the bottom with an old check valve, a big check valve. We've taken many of them out. That check valve over time would get clogged up with mud, and if there was a break behind that check valve, the boiler would drain itself out. There have been many explosions, kill people, before this Hartford loop, because what would happen is the super or the attendant would come back down, see that the water line was empty, and open the water. Open the water into a hot, ever put water on hot, flaming hot cast iron? You welders know exactly what I'm talking about. As soon as that water hits, boom. Well, that's what was happening. So this Hartford loop was devised by a gentleman from the Hartford Insurance Company. He had to figure out a way to keep the water in the boiler if the return pipe, which goes throughout the building, breaks. So he says, I want to keep this boiler filled with water at all times if that return line breaks. That's all it is. It's a safety device. It's an ingenious idea, and it works. And the idea, and if it ties into our boiler water line, it goes 4 to 6 inches below the operating water line. That will be right below the top tube. That will ensure that that boiler is not going to dry fire if all the controls fail and the boiler is drained out. Okay. Any questions? Nobody? All right. I only got a few more minutes. I'm going to get into just a little bit of A dimension. This is for steam distribution. The A dimension is an imaginary line between the boiler water line and the wet return throughout the whole building. When your boiler is filled up, you see this line here? Every pipe in the basement is filled up also, up to that line. That A dimension is required to get the condensate back into the boiler. And that A dimension needs to be 24 inches. Now what happens is, this will show you a little bit better. The reason 28 inches comes into play is because most steam systems are designed with the friction loss of half a pound, okay? So, and if you notice, by the way, it says 2 PSI, just give me a little note there. We're operating the boiler, the steam starts to head up into the system, the same pressure pushes down on the return. If you notice, there's a 2 missing. That's supposed to be 2.5. That actually adds additional pressure here. So you actually have about 2.5 pounds of pressure here, and you need to overcome this because this friction loss at the end of the line only has 1.5 pounds. 28 inches equal 1 pound. Okay, if you have, let's say you have 14-inch drop, what's going to happen is this water is going to push out of the boiler and back up into the steam main and start water hammering around up into the apartments. It's a very basic picture. It's a very, it's a rule that we go by. And the reason I'm telling some of you guys this is not necessarily you're going to use this every day, but you should know it because when you're a foreman or when you're a supervisor, if you're laying out the boiler room, that line's crucial to us. We all make mistakes. Usually the boiler's already sized and put into place when you get there. And it's not really your responsibility to check that, but you should know it. Because if you see something out of whack, and that's the time, actually the time is before we actually put the boiler in, that's the time to tell us. We don't want to pipe that boiler and say, hey, you know, we have a problem. If we have a D boiler, a very high water line boiler, and it's up in this area, there are other piping arrangements we can make to fix that. All right, so we don't want to pipe that boiler in through gravity. It's called a false water line. We'll get into that in a second. But the reason that should be important to you guys is that we want to know, we want you to be alert and to point it out. We can't see everything. We can't be in every place at all the time, and we need you guys to back us up. And eventually you'll be laying out these jobs. If I see a few of you guys, you know, in a few years, maybe just go in and lay these jobs out yourselves. You need to know this stuff. And there's a lot more detail to this, so I'm just sort of giving you the basics. Any questions on the A dimension? You have a question.
If we don't have that A dimension, what would be the result?
If we pipe it,
If you don't have the 28 inches.
if we don't have the 28 inches and we pipe everything properly, the way it is, without taking exceptions to that, we're going to have major issues. What we're going to do is we're going to fire up the boiler. We're going to start having water hammer. We're going to have a very unhappy client. They're not going to pay, excuse me. That's why it's important, because it won't work proper. And you're going to create chaos with the water hammer that bounces around in that steam system. It's going to wreck the radiators. You're going to have water shooting out of the vents. We're going to have water shooting out of the vents. And you're going to have some especially on Park Avenue. When you have that on Park Avenue, if you ever go into some of those apartments are worth more than, you know, all of us. You know, $5 million apartments, you have water, you know, mess coming out of the vents, messing up their beautiful hardwood floors. You're going to know about it. There's going to be issues. So this is why it's important that you understand this. It does have a direct result. Any other questions, Vin? That answer your question? There is a piping technique called the false water line that can fix that. That's already a Band-Aid, but we can fix it. We can make it a pump return, and we've done that only on a couple of occasions, maybe 2 or 3 times. I'm going to say in 28 years. I mean, however long I've been doing, putting these boilers in. There was 2 times we had to actually make a false water line because the wrong boiler was chosen. All right? Not a bad record in about 1,000, so it's not, you know, it happens, but. All right. There is some handouts. We were talking about dry steam. Why is that important? Can anybody tell me why dry steam is important? Well, in your handouts, it'll speak about it. We want the steam to be about 98% dry. That removes most of the moisture. Wet steam gives up its heat faster, cools down faster, and you have to reheat it to make steam. It's less efficient. It's more noise. It also causes water hammer. It causes the boiler to short cycle. All right, I went over the Hartford loop, the A dimension, and venting. I want to just touch a little bit on the venting. I have one more. Okay, it was on the last page. It's probably the most important thing in the one-pipe steam system. We're talking strictly one pipe. There's so many other steam systems that we could talk about. Right now, we're going into the basics, one pipe. When the boiler fires, the burner fires, it sends steam into the header. The header distributes the steam up into the radiator, okay, and through this little air vent. That air vent is very small. It will not remove all of the air that's in this chamber and inside the steam pipes. Therefore, we put a main vent on. That main vent, in simplistic terms, will do exactly that. It will remove the air very quickly. It's very important to remove the air out of the steam main very quickly because we would like to have that main filled up with steam before there's pressure on the boiler. It's an efficiency issue. That's one way to test it. If you ever go into a building, you want to start up a burner, you're doing troubleshooting. Anthony will be doing this eventually. You're firing the burner. You see that there's pressure on the needle. You go down to the end, and the end of that main is cold. That's a problem. It's actually like blowing into a straw with a 4-inch blower, and you just try and pushing all that air through a straw. It backs up, it builds up pressure. That's what happens in the boiler. As the burner's firing, making heat, the steam is trying to get out, but you can't have steam and air in the same medium, in the same pipe. It just doesn't happen. The air has to be removed before the steam will hit the pipe and give up its latent heat. That's why we want to get that main vented as quickly as possible. A good rule of thumb is to have no pressure and go out to the end of the main and feel that end of that main, and it's hot. And you see no pressure on your needles if you know you have good vents. All right. Also, if you hear the vents, if you hear them very loud, in the apartments, not enough venting in the building. You should be able to stand within 6 feet away from the radiator and not hear it. Okay? So if you hear a lot of air hissing, there's not enough vent. Let's talk about it. We could design a system. A lot of times you need more than one vent. You know, you see those, we're using Gordon number 2s. Gordon number 2 is a great vent because it actually has a capacity of, I think, 2.5 times the Hoffman vent, which was the vent that we used to use before I learned about Gordon vents. Those Gordon vents, you can put 2 or 3 of them on this main and have this heated up in 10 to 12 minutes, have the whole thing heated up. Then it's up to the radiators to do their job and remove the rest of the air, the riser vents.
When you have that steam traveling at that high pace, and you start to get knocked into certain radiators located at a part of the building.
What's your question? If you have steam running fast, I'm trying to understand your question. If you have steam.
Well, you said the steam is traveling fast. That means the vent is venting very fast.
That's what you want.
Okay. The radiator at the end is venting, but it's getting pregnant over here on this side of the building, but the radiator not hot. But the steam past that already.
There's probably could be a back pitch line Could be a back-pitched radiator, could be a local problem, could be a clogged vent. There's any number of things it could be. It could be overfiring the burner. There's a bunch of different things we could talk about.
But it only happened after you putting a quick vent on the other end.
Are you talking about a specific job? Okay. Let's go visit it. We'll figure it out. I can't see it in my head, so I don't know what you're talking about.
How I rectify that, I put back the slow vent at the other end, which stopped the banging, and everybody got heat.
Good job.
By extending the empty platinum.
Cycle, the heating cycle. Okay. You did what you needed to do.
He's saying sometimes too quick on the vent is damaging than helping, more damaging to the system. So you need to follow.
You could, you know what you could have? A clogged return.
Everybody got heat.
No. Hear me out. The system is designed to remove the steam, the main anyway, as quickly as possible. Okay? Now what happens is, as the water drips back down, it goes into a wet return. It's on the floor. It's going around the basement. It's going under doors through these series of pipe called the wet return. You could have mud and built up in that wet return. It could be so porous. Alex was telling me the story about, it's like a highway cop, okay? Telling me today. It's like a highway cop. The condensate is traveling back through hundreds of feet of pipe throughout the basement, okay? And it's like you driving down the highway and you see in your mirror, or you see in you have a detector, you see the cop up ahead. You got to slow down, okay? So you slow down, okay? And then you pass the highway cop, and then you take up again. Now you're going. See, what happens here is there's a clog here, okay? And the condensate's trying to move. And you hit that, that's the highway cop. It slows down, so it stops. So it backs up the water into the main, okay? Then you go another half a mile, see another highway cop. There's another clog right there, okay? That's a clogged return. And that will back up the main, and then we have to get into slowing everything down. The right way to fix that job would be to blow that main out or replace the returns on the floor. That would be the right way to fix that job. I contend that you cannot vent the main fast enough. As long as you're matched up with the firing rate of that steam system and that main is vented properly, that's the right way. So a lot of times our boilers are so efficient, even at the pinned firing rate, they're too fast. The steam comes out too fast. It's overwhelming that system. That's when you have trouble too, and that's when the only thing we could do is put in our potentiometer and Misha's come up with 100 other ways to fix it. But that, more than likely, will have a clogged return that's causing that problem. That definitely needs to be looked into more. All right? Any questions about water hammer? I mean, that's a whole seminar in and of itself. By the way, I did ask Dan Hallahan to come. We're trying to work out the details. I'm not sure I can get him there, but what I'm going to try to do is find out when he has a steam seminar and ask anybody who's really interested. We'll go to him, okay? If there's only 5 or 6 of us that want to do it, it'll work out. I think that's the right way to do it. And we'll be in his environment, in his area, and we'll learn a lot more than him coming here and maybe someone that's not interested in steam, that doesn't really need to pay attention there. See, I love it, so I'll watch him all the time. It's something that I really love to do. All right, any questions about that? There's a